Pressure measurement. What is meant by absolute pressure? The clearest reference pressure is the pressure zero, which exists in the air free space of the universe. A pressure which is related to this reference pressure is known as absolute pressure. For the required differentiation from the other types of pressure, it is denoted by the index ABS. ABS stands for absolute, which is derived from the Latin absolutus, meaning means detached or independent. Okay, so absolute pressure is nothing but this is a pressure measured with a reference point as a zero pressure, which exists in the air free space of the universe. Okay, absolute pressure. Come for the next slide. Atmospheric pressure. The probably the most important pressure for life on Earth is the atmospheric pressure. Ambient or ambient it represents. See, sometimes we may hear two terms, atmospheric pressure and ambient pressure. What is the difference between these atmospheric conditions and ambient conditions? Ambient conditions means close to the atmospheric conditions. Okay, close to the atmospheric conditions are called as ambient conditions. Okay, the most important pressure for the life on Earth is the atmospheric pressure. Okay, it is created by the weight of the atmosphere which surrounds the Earth up to the height of approximately 500 kilometers. Okay, up to this altitude at which the absolute pressure is zero and its magnitude decreases continuously. Furthermore, the atmospheric pressure is subject to weather dependent fluctuation, as is only too well known from the daily weather report. At sea level, atmospheric pressure averages 1013.25 hectopascal, corresponding to the 1.01325 millibar, which cyclones and anticyclones, this pressure varies by 5%. Hectopascal is nothing but kilopascal. Okay. Uh, Not kilopascal. 1013.25. 123. If you want to express it in a bar, we can read it as 1.01325 kilopascal. Kilopascal. Understand? Simply a pascal. 1.01325. Okay, kilopascal or simply 1.01235 into 10 to the power of 5 Newton per meter square or simply 1.013 bar. Okay, this is the atmospheric conditions. We can express these atmospheric conditions in terms of mm of Hg also, centimeters of Hg also. 76 centimeter of Hg or 760 of Hg is treated as the atmospheric pressure. Okay, come for the next slide. Over pressure as gauge pressure. The most frequently measured pressure in the technological field is the atmospheric pressure differential. Okay, it's a difference between absolute pressure and atmospheric pressure. Okay, this is known as the gauge pressure. Simply, a gauge pressure is a pressure measured by a pressure measurement gauges, or if you measure the pressure by any other instrument, and we can call them as a gauge pressure. This gauge pressure is represented above the atmospheric pressure. Understand? Gauge pressure always measures above the atmospheric pressure. That is the thing we have to remember. If the pressure is less than the atmospheric pressure, then that is called as a vacuum pressure. differential pressure. The difference between two pressures P1 and P2 is known as the pressure differential. Okay, delta P is equal to P1 minus P2. In cases where the difference between two pressures itself represents the measured variable, one refers to the another pressure. Okay, delta P is nothing but pressure difference or differential pressure. You are seeing a simple structure. uh, can you please zoom that value so that we can visualize it clearly? This is the atmospheric pressure. Pressure above the atmospheric pressure line is called as gauge pressure, and the pressure below the atmospheric pressure is called as vacuum pressure. Understand? Okay, gauge pressure. This gauge pressure is nothing but measuring the pressure by keeping the atmosphere pressure as the reference point. Okay, and measuring the pressure above the atmospheric pressure. Whereas the vacuum pressure measured below the atmospheric pressure is called vacuum pressure. Okay, the Pascal. Here we are seeing simple diagram. Here, what is the meaning of pressure? Pressure is nothing but force acted upon Newton meter area. Force acted upon meter area is called, or unit area is called pressure. Understand? Here we are creating certain pressure. This is called as a hydraulic press. Understand? This is the principle we may use in weighing machines. Okay, in outside and the nearby the highways, we can measure the weight of the trucks. Understand? Goods trucks or empty vehicles. Okay, this is the hydraulic lift principle. Okay, by here we are creating certain pressure. Understand? This is the fluid, hydraulic fluid. As we are applying certain force here, that force will makes the fluid, and it excites. Okay, this fluid will exert certain force on this, and we can lift the vehicle also. Here pressure force is P1A1, and here pressure force is P2A2. In our 8th standard onwards, we have studied Pascal. Means the intensity of pressure is same in all directions. The intensity of pressure is same in all directions is called pressure law. Yeah, Pascal law. Pressure is equal to the force divided by the area on which it acts. According to the Pascal's principle, in a hydraulic system, pressure exerted on a piston produces the equal increase in pressure on another piston in the system. If the second piston has an area 10 times of that piston, the force on the second piston is 10 times greater. Through the pressure is same as that on the first piston. This affects the exemplified by the hydraulic press based on the Pascal, which is used in such applications as hydraulic brakes. Okay, intensity of pressure is same in all direction. See, this is the piston. Pressure is P1. Okay, this is the another piston. Pressure is P2. Understand? Force is same. So P1 being pressure is same. Pressure is same. So if the piston say area is very much, therefore exerting pressure is higher. That is why by applying a small press, small pressure force, we are lifting the a big vehicle. Understand? In both cases, intensity of pressure P is same, but whereas the areas are different. Understand? So by using this principle, by applying small force, we can lift the big vehicles also. Okay. The Pascal is also discovered that pressure at any point in a fluid at rest is the same in all directions. The pressure would be the same on all planes passing through a specific point. This fact is also known as Pascal principle or Pascal's law. Okay. What is the internal meaning? The pressure at a point in a fluid at rest is same in all direction. In a static fluid, pressure at a point is same in all directions. This is now given by the Pascal. Okay, that is why we are calling it as a Pascal law. Now, pressure measurement. Pressure measurement is done by the manometers. Using manometers, we can uh, we can done the pressure measurement. You are saying manometer. What is meant by manometer? Manometer is a device which is used to measure the pressures. A common simple manometer consists of a U-shaped tube of glass filled with some liquid. Understand? Here, green color is indicating certain pipe. Understand? Here we want to measure the we want to measure the pressure at this location. Okay, so this is the U-tube manometer. Why we are calling it as a U-tube? Its shape is in U. That is why we are calling it as a U-tube manometer. This U-tube manometer has two limbs. This is left limb and this is right limb. Left limb is attached to the pipe, at which point we have to measure the pressure, and other limb is left it for atmosphere. Understand? So because of the, see, this is the because of the pressure inside the fluid flowing through a pipe, this liquid is pressing the manometric fluid. The manometric fluid is nothing but the fluid presented in the manometer. Understand? We can use mercury or we can use water as the manometric fluids. Understand? Here we are seeing two levels, H1 and H2. H1 is the level of the liquid of pipe fluid, and where is the H2 is the level of liquid in a manometric fluid. Understand? Length of liquid and length of manometric fluid. Okay, and differential manometer. See, a differential manometers are used to measure the difference of pressure between 2 points in a pipe or in. There are two types. Understand? What is meant by differential pressure? In the previous slide we discussed. Differential pressure is nothing but pressure difference between the 2 points of same pipe or at two different points of two different pipes. That is called as the pressure difference. Understand? So these YouTube differential manometers are two types. One is YouTube upright differential manometer. Another one is YouTube inverted differential manometer. See, YouTube upright differential manometer we are seeing. Okay. Um, pipe A, this is A, and this is the pipe B. Through pipe A, different fluid is flowing. Through pipe B, different fluid is flowing. Understand? So we have to find out the pressure differences between two liquids of two pipes. Understand? So here H1 is the height of the liquid, height of the liquid in the pipe A. Okay, and and uh, H2 plus H3, H2 plus H3 is the height of the sorry please, H2 is the height of the manometric fluid and H3 is the height of the liquid B in the which is flow pipe B. This is the reference level. This is the reference level. By using Pascal law, intensity of same. Okay, pressure on the left side is equal to pressure on the right side is pressure on the left side is equal to the pressure on the left side. Understand? By using this, we can find out the pressure difference, PA, atmospheric pressure, and see what are the parameters we need to calculate the pressure difference means pressure density. Okay, rho is the density of pipe A fluid, and rho B is the density of the liquid flowing through the pipe B, and rho M is the density of the manometric fluid presented in it. Okay, this is a simple structure or schematic diagram which shows the its cross section. Understand? Come for another one. And this is the inverted YouTube. Okay, uh, previous one is upright differential manometer, and this one is the inverted YouTube manometer. What is the difference between in these two means rho m is the density of manometric fluid. Density of manometric fluid. Rho 1 is the density of the fluid in left side pipe. Rho 2 is the density of the fluid in right side. Understand? This is the common level. Okay. So, sorry, this is the common level. H2U, H1. So, by using the pressure equations, we can find out the pressure difference P1 and P2 in problems. We will discuss them. One more thing, hydrostatic pressure described in hydrostatic pressure. Describe the increasing amount of pressure that water exerts as it gets deeper. The what is meant by hydrostatic law? Okay, one. Hydrostatic law states that the rate of increase of pressure in a vertically downward direction in a fluid or liquid is equal to the weight density of the liquid. Okay, hydrostatic law states that the rate of increase of pressure in a vertically downward direction in a fluid or liquid is equal to the weight density of the fluid. Understand? Dou P the construction and arrangement of manometer connected at two different points A and B. Pipe B shown in the previous figure. We had seen this pipe A and okay, pipe A and pipe B showing two different points, two different points at two different pipes. Understand? What is the difference between simple YouTube manometer and differential manometer? Means by using simple manometer, we can find out the pressure at only one particular point only, only particular point. Understand? Whereas this differential manometer, we can find out the pressure difference between two different points, two different points. Okay, that is the thing. Hydrostatic law is a principle that identifies the amount of pressure exerted at a specific point in a given area of liquid or a fluid lying on the top of a surface. See, as the height is increasing, the rate of pressure change is also increasing. Understand? And that increase in pressure is equal to the weight, specific weight. For example, dou P by dou Z. Dou P by dou Z is the rate of change of pressure, and W is its specific weight. From hydrostatic law, we can say that dou P by dou Z is equal to a specific weight W. Specific value W is nothing but rho g. Therefore, dou P by dou Z is equal to rho g. In next step, we will get a dou P is equal to rho z into dz. If we integrate it, we will get P is equal to rho g z. P is equal to rho g z. Okay, this is the meaning of hydrostatic law, mathematical expression for this hydrostatic law. Hydrostatic pressure describe the increasing amount of pressure that water exerts its gets its deeper. The French scientist Blaise Pascal wrote a principle relating to hydrostatic pressure that states that when one part of a body of water is pressurized, the pressure transmits through the entire body of water without diminishing. The formula for the Pascal hydrostatic principle P is equal to P atmospheric ATM stands for atmospheric pressure. Atmospheric pressure plus gauge pressure. Okay. Hydrostatic Pascal's hydrostatic principle. This principle is the basis for hydraulic system and can be seen in action in a hydraulic pump system that places pressure on a column of water on one side in order to exert that force on the other side of the column. For instance, if U-shaped pipe is has a value that applies downward force on the left arm, that U and a moving plate on the U's right arm. The pressure applied by the valve on the left will cause the plate to move on the right. Even though this force on heavy loads, including cars and boats, by applying small force by using the hydraulic lifts, we can lift the cars, trucks, and large boats also. Okay, before closing the session, once again, we will go through all these, we will recall them, okay? Recall them once again. Pressure measurement, okay, what, absolute pressure. The clearest reference pressure is the pressure zero, which exists in the air-free space of the universe. A pressure which is related to this reference pressure is known as absolute pressure. For the required differentiation from other types of pressure, it is denoted with the index ABS, which is derived from the Latin absolutus, meaning detached or independent one. Okay, and next one, atmospheric pressure. The probably most important pressure for life on Earth is atmospheric pressure. Okay, it is created by the weight of the atmosphere which surrounds the earth up to a height of approximately 500 kilometers. Okay, up to this altitude at which the absolute pressure is zero, its magnitude decreases continuously. Furthermore, the atmospheric pressure is subjected to weather dependent fluctuations, as is only too well known from the daily weather report. At sea level, atmospheric pressure averages 1.01325 kilopascal, or simply 1.01325 bar. Okay, and gauge pressure. The most frequently measured pressure is the technological field is the atmospheric pressure differential. It is the pressure difference between absolute pressure and the relevant atmospheric pressure. Is known in short over pressure or gauge pressure. In the simple words, gauge pressure is the pressure measured by any other gauge, okay, or any instrument. A positive over pressure is referred to when the absolute pressure is greater than the atmospheric pressure. Yeah. Okay, this gauge pressure is always measured above the atmospheric pressure. Understand? If we measure the pressure below the atmospheric pressure, then that is called as a vacuum pressure. Okay. Now, what is meant by differential pressure? The difference between two pressures P1, P2 is known as the pressure difference. Okay, this pressure differential may be the difference of pressures of at two different points of the same pipe, or pressure difference between the two different points on two different pipes. Okay, that is called as the differential pressure. And here we are seeing one graphical representation on the paper. Okay, atmospheric pressure is as the reference point. Gauge pressure is lying above the atmospheric pressure, and vacuum pressure is represented in below the atmospheric pressure. Understand? So pressure measured above the atmospheric pressure is called as gauge pressure. Pressure measured below the atmospheric pressure is called as a vacuum pressure. Okay. Pascal law. It states that intensity of pressure is same in all directions. Intensity of pressure is same in all directions. Pressure is equal to the by the area on which it acts. According to Pascal's principle, in a hydraulic system, pressure exerted on a piston produces an equal increase in pressure on other piston in the system. If the second piston has an area 10 times that of the first, the force on the second piston is 10 times greater. Through the pressure is the same as that on the first piston. This effect is this effect is exemplified by the hydraulic press based on Pascal's principle, which is used in such applications as hydraulic brakes. Pascal is also discovered that pressure at a point in a fluid at rest is the same in all directions. The pressure would be the same on all planes passing through the specific point. This fact is also known as Pascal's principle. Manometer. How can we measure them? How can we measure the pressure? Means pressure measurement by two things. That is manometers. Okay, manometer is a device to measure pressures. A common simple manometer consists of a U-shaped tube of a glass filled with some liquid. This is the U-shaped tube. Understand? That is why we are calling it as a U-shaped manometer. A fluid or a liquid which is manometer is called as manometric fluid. This one limb is connected to the, that is the left limb is connected to the pipe at which we have to measure the pressure, and the right limb is left to the atmosphere. So here atmosphere will acts, understand, because of the atmospheric pressure this will moves up into the pipe. So these pressure differences will help us to find out the pressure. Differential manometers. Differential manometers are used to measure the difference of pressure between two points in a pipe or in two different pipes. There are two types of differential manometers: U-tube upright differential manometer and U-tube inverted differential manometer. This is a U-tube upright this differential manometer. So pipe A and pipe B, two different pipes and two different points. Understand? We are measuring the pressure differences between these 2 points. Understand? This is the inverted. This is the inverted U-tube manometer. This inverted U-tube manometer is used to find out the pressure difference. So how to limit the usage of that upright and this inverted means, if pipe fluid is lighter fluid than manometric fluid, then we will use that simple upright one. If manometric fluid is lighter than the pipe fluid, then we will use this inverted U-tube manometer. Hydrostatic law is the principle that identifies the amount of pressure exerted at a specific point in a given area of fluid lying on top of a surface. Surface. It can also refer to the overall weight of the fluid. Okay. As as the amount of pressure is exerted at a specific point in a given area of fluid lying on a top surface. The Hydrostatic, hydrostatic pressure describes the increasing amount of pressure that water exerts as it gets deeper. The French scientist Blaise Pascal wrote the principle relating to hydrostatic pressure that states that when one part of a body of water is pressurized, the pressure transmits throughout the entire body of water without diminishing. This formula of Pascal hydrostatic principle is P is equal to atmospheric pressure P ATM plus PG. P ATM stands for atmospheric pressure. PG stands for gauge pressure. The principle of this is the basis for hydraulic systems and can be seen in action in hydraulic pump systems that place pressure on a column of water on one side in order to exert that force on the other side that column. For instance, if a U-shaped pipe has a valve that applies downward force on the left arm of U and moving plate on the U is right arm, pressure applied by the valve on the left will cause the plate to move on the right. Even given enough force, this force can lift heavy loads, including cars and large boats. Hydrostatic law states that the rate of increase of pressure in a vertically downward direction in a fluid or liquid is equal to weight density of the liquid. Hydrostatic law states that rate of increase of pressure in a vertically downward direction in a liquid or a fluid is equal to weight density of the liquid. Okay, this is the simple summary on the pressure measurement. See, these are only the simple manometers. Understand? Mechanical gauges are also there. Mechanical gauges. Understand? What are the means? Bellows pressure gauge, Borden's pressure gauge, liquid column balancing, a spring-loaded pressure gauge. All these are the examples for mechanical gauges which are used to measure the pressures. Okay. By now I am closing the class. Monday we will meet you again. Okay. Thank you. You can leave.